Hi, Level 3s. This is an introduction to mechanics. So the first part of Chapter 8 in your Bendel textbook contains a revision of Level 2 physics. And so you need to be able to grasp these ideas in order to move on. So we'll start off looking at motion, scalars and vectors, and then we'll look at forces, Newton's laws, resultant forces, and components. And then we'll do a couple more lessons to cover the 10 pages after that. So first up, can you remember what vectors and scalars are? You can go and have a look at this Khan Academy video if you didn't do this last year or you can't remember. Just Google Khan Academy Introduction to Vectors and Scalars and the video will come up. You can watch that. To summarize, scalars are quantities that have got magnitude only, so a numerical value, whereas vectors are things that have both magnitude and direction. And here's a couple of examples down here. So distance is a scalar, whereas displacement is the vector quantity associated with position. So the symbol is a D with a line on top to indicate that it's a vector. It's also measured in meters, but the displacement is the total from the start. So if you go all the way around in a circle and you end up where you started, your displacement is 0. Also, as displacement, you must have a direction as well. We don't often use displacement, but it's just something to be aware of, and we'll talk about it more when we look at forces and resultant forces. The next thing is speed. Speed is a scalar, and velocity is its vector. Again, you need to have both a number, numerical value, and a direction for velocity. And there is no scalar for acceleration. Acceleration is a vector. It's measured in meters per second. Right, so the way to show a vector is to actually have an arrow on top of it, or to have a little squiggle underneath it, or to have a line on top of the symbol. Right? We also know that velocity is displacement over time or distance over time. And acceleration is the change in velocity over the change in time. You would have seen that last year. Can you remember what Newton's first law is? Pause the video and have a quick think about that. So we speak about it often as inertia. So when an object is at rest already, will stay at rest, or if it's in motion, it will stay in motion in the same speed, with the same speed in the same direction, unless it's acted upon by an unbalanced force. Can you remember anything about Newton's second law? Have a pause again, think about it. So it talks about the behavior of objects for which all existing forces are not balanced. So an acceleration of an object depends upon the net force acting on it and the mass of the object. And the equation for that was F equals ma. Therefore, A equals F over m, force divided by motion. I'm going to talk about resultant forces next. If you go and have a look at the Physics Classroom website, and take a look at the physics tutorials called Vectors, Motion and Forces in 2 Dimension. Click on that. It will take you here and go to, there's quite a lot here that you can look at, but right now let's look at resultants. And if this rings a bell, if you've got a number of vectors, example A, B, and C, added head to tail, then the resultant is drawn from the start of the first one to the end of the last one. And you can work through these pages. They're quite useful. Again, A, B, C added together, head to tail, and the resultant is from the start of the first one to the end of the last one. So that's your vector addition method. And then if you click on the Physics Interactive, or you can just go Physics Interactives, Vectors, and Projectiles, there is an actual interactive here. And I've given you a screenshot of it. So let's say we take something like this and we put a vector up here, and now we add another vector to it. So this is my head to tail method. What do you think the resultant is going to be? Any ideas? And if you're not sure, you can click on show resultant, and that will be the resultant there. So you can have a good play with this. You can see that as you move things around, you're going to get a different resultant. Obviously, you want to make sure you close your triangles. So it's head to tail, so that one to that one. If we move this, the resultant changes. Always end up with, if you don't have head to tail, do you notice that the resultant stays the same? So that is incorrectly drawn, but it's the same as if this were just moved to over there. So head to tail is the way to draw. Another thing that we can do is look at the components of a vector. So those are the two, the x and the y, that make up a vector. So you can see if we move this vector on the horizontal, we're hardly going to be able to see the vector in the vertical. But the more vertical this vector becomes, the taller the component in the y direction. You can see we can move it around. Right? If we add another vector, let's say we add it on here, head to tail, then you can see its components. If we show the resultant, then it would make sense. If you have a look at the grey, add the grey, take away the grey in the vertical, then this is the resultant, which would make sense. Two horizontal arrows in grey add up to make the pink one, and the two vertical arrows in grey, this one points downwards, add up to make the pink one again, which will be 0 because they are the same length. So you may want to have a play with that one, components of a vector. So to take it further, we're going to look at a force, and I've just got this picture here. If you take the force, the vector, let's call it F. That's the force that the dog's been held at. It looks like a rod, not a collar with a reasonable chain. But anyway, so if we look at the components of that vector, you can see we've got the red line and the purple line. So together these two would make up the black line. So we've found that the black line, if you subtend it to the y-axis and this black line subtended to the x-axis, that's where the two vectors would be, right? If we find the angle between that force and either the x or the y, I've chosen to find the angle between F and the x-axis, and we call that angle theta. We can move the red arrow across just to make our lives a little bit easier, and we can then find, using trigonometry, as long as this angle here is a right angle, remember, then we can use SOHCAHTOA to find this length, and that length will be given by F sine theta because it's opposite of a hypotenuse. So FV over F equals sine theta, therefore FV equals F times sine theta. Similarly, the horizontal component can be found, which would be, according to SOHCAHTOA, because, which is adjacent over hypotenuse. And again, if you need more help with that, go back to the physics classroom, go find the physics tutorials and vector components, and there's a very good explanation about components here, and you can work through that. So coming back to boo-boo, sit boo-boo, we can note that what the equations are that we need to use. You might want to write that down. And then finally, you can review some of the resolution of forces in the physics classroom as well, which is a useful topic, a very useful page. And then in class, we'll go over how to do vector subtraction. We'll work through the examples and we'll do the practice problems or problem in your text.